In this video, we are going to continue to do problems with conversion factors, but these are going to be more specific to clinical problems. Then we are going to be discussing the topic of density. So, when we are dealing with conversion factors in clinical problems, understand that there's going to be, in essence, two problems that you will be tested on in this class. The first type of problem, which is what you have illustrated in this slide, is when you have a prescribed order for a medication, and based on that prescribed order, you need to find how much to give the patient. The next problem addresses a little bit of more complex problem. So let's deal with this one. The problem reads, a doctor's order prescribed a dosage of 0.150 milligrams of Synthroid. Think Synthroid is going to be your medication. If tablets in stock contain 75 micrograms of Synthroid, how many tablets are required to provide of this prescribed medication? So the first thing that you have to do is state the given quantities. So in this case, what you know is the dosage at which you need to give it to the patient. So the prescription. Which is in this case 0.150 milligrams. Then you need to find what is given to us, which is the stock that we have of the medication. Which, in other words, that is your clinical factor. And that states that one tablet of this medication is going to be 75 micrograms of the medication. Okay? I'm just going to put Synthroid. I'm just going to do it as a med. So you need to give this patient 0.150 milligrams of the med, and then you have in stock one tablet that contains 75 micrograms of the med. So how do we deal with this problem? Understand that in order to do this problem, we need to write a plan in order to convert the given unit to the needed, and we need to state the equalities for the conversions, which is pretty much what I did for writing what is given in the problem. Then we have to set up the problem. So one of the things that I want to highlight for this problem is that the units for the prescription are in milligrams, but what you have available is micrograms. So what does this mean? That the units of what is needed to give to the patient and what you have in your tablets are not the same. So what you should do as a first step when you're solving the problem, the first step, okay, is going to be, if needed, and in this case is needed, to convert milligrams to micrograms. Okay? Again, when you're doing milligrams to microgram, this is a metric to metric conversion. And in this metric to metric conversion, I'm going to go back into the slide that contains the number line method. So we see, okay, how many places I'm going to move this decimal place. So let me just go back to that number line so we see it. Let me just erase the work that I have here, which is for the previous video. So in this case, for our current problem, we are given milli. We need to walk to micro. So as you can see, we're going to move that decimal place 1, 2, 3 times from left to right in order to convert the milligrams to micrograms. Let's go back to the problem that we are working on. So in this problem, then we know that 0.150 milligrams is going to be 150 micrograms, okay? And now that we have converted the prescription or the dosage that we need to give the patient to the stock or the clinical factor that we have for this medication, then we can solve the problem. So how are we going to do this? Again, dimensional analysis. So you know that what you need to give the patient is 150 micrograms of the medication. Then here you're going to be using your clinical factor as your conversion factor. So, similar to what we did before, when we are doing this, then in the bottom, we need to match the unit that matches those micrograms, which is going to be 75 micrograms. We are going to put on top what it equals to, which is 1 tablet. So the units cancel, micrograms with micrograms. So when you take 150 and you divide it by 75, you see that to this patient, you need to give 2 tablets. Let's do another type of clinical problem. As you can see in this, the problem reads, a children's chewable Tylenol contains 80 milligrams of acetaminophen per tablet. If the recommended dosage is 10 milligrams per kilogram, how many tablets are needed for a 40-pound child? So in this type of clinical problem, as you can see, you have given the medication, you're given, which in this case, let me just do it in a different color, is going to be 1 tablet equals 80 mg. You're given the dosage that you need to administer it at, which is 10 milligrams per kilogram of body weight. And lastly, you're giving the weight of the patient, which in this case is a 40-pound child. So those are the 3 pieces of information. So in this type of clinical problem, understand that the way that we solve it is in the following manner. First, you're going to take the weight of your patient and you're going to change it into kilograms. So in this case, you're going to say 40 pounds and you're going to convert it to kilo. Again, this is a metric US relationship in which you know that 2.20 pounds equals 1 kilogram. Again, I'm utilizing dimensional analysis in order to solve this. So when it comes to this, I take 40 and I divide it by 2.20, okay? And I get a series of numbers. So let's just keep it at least 3 decimal places because that will get you close enough to the final answer. So in terms of kilograms, this is going to be 18.182 kilograms, okay? So step 1, we're going to change the weight of the patient to kilograms. Step 2, we are going to then utilize our dosage in our medication in order to find out how many tablets we need to give this patient. How do we do that? Well, we are going to write the result of step 1, which is 18.182 kilograms. Then we are going to use the 2 conversion factors that we have. That's why dimensional analysis is so important. The first one that you're going to set up here, okay, is going to be the dosage one. Why? Because the dosage one is the one that has the unit of kilogram. And you know that based on that dosage, that per kilogram, you need to give this patient 10 milligrams of this medication. The next equality that we're going to use is going to be the medication that we have in hand. In this medication that we have in hand, then how do you know how you're going to set it up? Well, remember, as I mentioned before, in dimensional analysis, these kilograms cancel with these. So here, the milligrams have to be in the bottom because I need to cancel it with the milligrams that I have on the top. So here I'm going to put 80 milligrams. Then I'm going to put 1 tablet on the top. The milligrams cancel each other. And then my results is going to be in tablets, because that unit I'm not going to cancel. Now, when it comes to this, I'm going to take that 18.182 and I'm going to multiply it by 10. I'm going to multiply it by 1. And then I'm going to divide everything by 80. And as you can see, your calculator display is going to give you 2.27272727. In this case, we are going to keep it as a whole number. So we're going to give us a final answer, 2 tablets. When it comes to clinical problems, I will say how many sig figs I want reported in the answer. Okay? So when it comes to this, as you can see here, we have 2 problems that you guys can use in order to practice. There's actually in the worksheet 4 problems total, but I'm going to go over specifically problem 2 and problem 4. So on problem 2, it states your patient has a headache but has difficulty swallowing pills. Your physician orders acetaminophen 750 milligrams every 4 to 6 hours. You have acetaminophen elixir that is 150 milligrams in 5 milliliters. How much will you administer every 4 to 6 hours? So in this problem, it's going to be similar to the first type of clinical problem that we talked about. You are given a medical order or a specific dosage that you need to administer the patient, and you have a particular form of the medication. So when it comes to this, all you have to do is say, okay, the order, the prescription, the dosage that the doctor wants me to have. So let's just call it orders for the physician orders. In this case, it's going to be 750 milligrams, and you have to give those every 4 to 6 hours. Okay? Then you understand that your clinical factor, which is the medication that you have in hand, is going to be 160 milligrams per every 5 milliliters. So in this problem, the way that we solve it is that we say, okay, my order and how much of the medication, which I highlighted in green, match in terms of units, so there's no conversion needed. So what I'm going to write is the order that the doctor gave me for that particular medication, and then I'm going to use as a factor my clinical factor. So my conversion factor here is going to be my clinical factor. So what does this mean? That in the bottom, I'm going to put 160 milligrams. On the top, I'm going to put 5 milliliters. And when I take 750 times 5 and divide it by 160, if we report it as a whole number, I'm going to report it as 23 milliliters. Remember, in these problems, I tell you how many sig figs you need to be reporting. Let's do problem 4. In problem form, as you can see, it says you have in hand or on hand hydromorphone at 4.0 milligrams per milliliter. You need to administer 0.015 milligrams per kilogram to a patient who weighs 150 pounds. How many milliliters should you administer? Okay, so remember, let's write down what is given in this problem, which is going to be the weight of the patient, or the body mass, which is 150 pounds. We have the dosage at which we need to give it to the patient. Which is 0.015. Let me just write those numbers more clearly. Per 1 kilogram. And lastly, we use as a clinical factor what we have in hand of this particular medication. So my clinical factor is going to be 4.0 milligrams, okay, per 1 milliliter, okay? As I explained before, the first step when solving these problems is going to take those pounds and convert them to kilograms. So in order to do that, you're going to say 150 pounds, 1 kilogram on top, 2.20 pounds in the bottom. So when I take 150 and I divide it by 2.20, then again, round it to 3 decimal places. I find 68.182 kilograms. The pounds cancel. Then, now that I have this result, on step 2, I'm going to be using my dosage and my clinical factor to find out how much or how many milliliters I should administer of this particular medication. So in this case, as you can see, I have 68.182 kilograms. Then I'm going to do 2 conversions, in which the first one is going to be my dosage, and the next one is going to be my clinical factor. So when I utilize my dosage, again, in the bottom, I'm going to say 1 kilogram because that's the unit that matches. On top, I have 0.015 milligrams. The kilograms cancel. Next fraction, which is the clinical factor. Again, I'm going to use my clinical factor and put it as a fraction in which the bottom has to match the unit that I have on top, which is 4.0 milligrams. And on top, I'm going to put 1 milliliter. The milligrams cancel. So then my final answer is going to be in milliliters. Let's say that for this case, I'm going to write 2 decimal places, that I ask you guys to put this answer in 2 decimal places. Understand that when you go to nursing school, kinesiology, wherever your next path takes you, or for my dental hygiene students, understand that it's going to depend on the instrument that you're using for delivering a particular medication. That's what it's going to depend. But in this class, again, to make it easy, I tell you how many significant figures I want at the end of the day. And in this one, I just want 2 decimal places. So when I take that 68.18 and I multiply it times 0.015 times 1, and I divide the whole thing by 4, then you find that in this case, you find the result to be 0.25568. If we round it to 2 decimal places, your final answers will be 0.26. So in this chapter, the last topic that we need to cover is density. And understand that when it comes to density, density is a property that compares the mass of an object to its volume. This is going to give you, specifically, as you can see here, is going to be given by the equation density equals mass over volume, or in other words, D equals M over V. Taking that into consideration, why is density so important? Because in density, we can actually tell if objects are going to float or they can sink depending on what we have. So if we zoom in into the beaker here that we have with different substances, again, we have a total of 5 substances in which water is the one that is in larger amount. So we're going to compare everything to water. Here, as you can see, because cork and ice are less dense than water, that's why they float. Aluminum and lead, because as you can see that the density is higher than water, they are going to sink when we place them all in a beaker. In table 2.9 in your textbook, as you can see, we have the density of some common substances. You guys don't need to memorize these values, but this is something to be familiar with of why these properties that we observe in the image that we have in the bottom left corner of the slide do happen. Now, what are you guys responsible for knowing when it comes to density? You need to know how to do density calculations, okay? So here, I'm going to write out the equations for density, and then I'm going to do 2 density problems just to give you feedback on how do we do these density problems. Well, as you can see, what is the equation to determine density? Well, it is D equals M over V, because density equals mass over volume. So utilizing algebra, we can actually separate the different terms. So given the first equation, what is the equation to determine mass? Well, mass is going to be density multiplied by volume. Again, given the first equation, we can even solve for volume, which states that volume equals mass over density. When it comes to quizzes and exam, you guys need to be familiar with all 3 equations. Let's now move on to problems. As you can see here, problem 1 says, a piece of tin has a mass of 16.52 grams and a volume of 2.26 centimeters cubed. We're trying to determine density. So in this problem, again, we're given mass, we're given volume, we have to determine density. So which equation you're going to use? The first one. You're going to say density equals mass over volume, which means that I'm going to say 16.52 grams. I'm going to divide it by 2.26 centimeters cubed. So that means that the unit for density is going to be grams per centimeters cubed. Okay? So when it comes to this, and I take these two numbers, understand that I need to round to the correct number of sig figs. In this value, we have 4 sig figs, 3 sig figs. So your final answer needs to be reported in 3 sig figs. So when we do this, understand that your final answer for tin specifically is going to be 7.31 because we rounded to 3 sig figs. Let's move on to question 5. Again, you have another 3 questions that you can practice on your worksheet. As you can see, in this one, we have to do volume, but specifically we want that volume in liters, okay? Now, we know that our metal, in this case, is 325 grams, and our density is 9.0 grams per centimeters cubed. So, when it comes to this, understand that for problem 5, because we want volume, we're going to use that third equation, which states that volume equals mass over density, which you're going to tell yourself, okay, I have 325 grams of this metal. I'm going to divide it by the density, okay, which in this case is going to be specifically 9.0 grams per centimeters cubed. So when I do this division, okay, and I round it to the correct number of sig figs, this has 3 sig figs, this has 2 sig figs. So I'm going to round my final answer to 2 sig figs, okay? Then I notice that my final answer here is going to be 36, okay? In this case, centimeters cubed. So I'm not done. Because remember that the question asks, what is the volume in liters? And for some of you, you'll be like, centimeters cubed, how am I going to relate that to liters? Well, understand that 1 centimeter cubed equals 1 milliliter. So centimeters cubed or cubic centimeters can be interchanged with milliliters. So this will be the same as saying milliliters. So what does this mean? That this answer actually is like saying 36 milliliters. So then, to do the final answer, you need to convert those milliliters to liters. So again, you will go back and utilize the number line method. In the number line method, if we go back and utilize it, okay, I'm just going to move back to that slide where we have it. Let me just zoom in. Let me erase the work that we did previously. For that, we're converting from milli to the basic unit of liters. So we're going to be moving that decimal place 1, 2, 3 to get to liters. So what does that mean? Like if we go back to our problem, if I take 36 and I move that decimal place 1, 2, 3, this is where the decimal place is going to be now. I have to add a 0 because I created that well. So 36 milliliters, it is actually 0.036 liters. And that is the final answer for that problem. Make sure that whenever you have density problems, you read the question and you see what is the final unit that it is required for the problem.